Welcome to the deep dive. We're here to plunge into those currents of information, find the hidden gems, and, well, turn complex stuff into real insight. Today, we're looking at something pretty unexpected, actually. It's a big strategic move from Innolux. You probably know them for display panels, right? Screens.
Mhm.
But they've made this, frankly, incredible leap into high-end semiconductor packaging. It's a technology called FOPLP. So our mission today, let's unpack how a screen company is getting into chip packaging, maybe even revolutionizing it, and figure out what that really means for tech for the industry. This isn't just some side project, it feels like a major shift.
It really is fascinating because, we talk a lot about the chips, the processors, the brains, but the packaging, that's absolutely critical. It's often overlooked, but it's how these tiny, powerful things connect to everything else, how they get rid of heat, how they fit into, well, everything. And what Innolux is doing here is not just a small technical adjustment. It's more like a fundamental rethink of how they can use what they already know to jump into a totally different high-value part of the semiconductor world. It could really redefine who they are as a company.
That sets it up perfectly. Okay, so let's get into the tech itself. Chip first, fan out, panel level packaging. FOPLP, that name already gives us some clues. What does chip first actually mean here? Why is that specific order important and panel level processing?
Yeah.
How's that different from, the usual ways? What's the big win there?
Great questions. So chip first uh, basically means the bare chip, the silicon die itself, gets placed onto the substrate before anything else. Then you build these intricate connecting layers, the RDL's redistribution layers on top. Think of them like tiny microscopic wires fanning out. Now, doing it chip first is, well, it's really beneficial. You get shorter electrical paths, which means better signals.
Okay, better performance.
Exactly. And it's also much better for getting heat away from the chip, and that's just crucial for the high-performance stuff. High-frequency chips, high-voltage power components, really dense ICs that, generate a lot of heat.
Right.
Now, panel-level processing, this is where Innolux's background really comes into play. It's their secret weapon, almost. Instead of processing chips on those relatively small, round silicon wafers like usual, they use their know-how to work on much larger rectangular glass panels, like the ones used for displays. Imagine making, I don't know, one giant cookie sheet of chips instead of lots of small, round ones.
Ah, okay, scale.
Precisely. Scale. It dramatically lowers the cost for each chip because you're making so many more simultaneously. Plus, it gives them way more flexibility in production. And the fact they've hit a 10-micrometer line width already that's incredibly small, 10 millionths of a meter, that tells you they've really cracked some tough technical nuts. Things like alignment, etching. It's impressive stuff.
It really does sound like they've nailed the technical side. So with this kind of advanced packaging, where are we actually going to, see it? What kinds of devices, what systems are using this FOPLP or could use it soon?
Yeah, you'll find this tech in some really critical spots. Think about power management ICs, PMICs. They're kind of the unsung heroes managing power in almost every gadget you have. Your phone, your laptop.
Right, keeping things running efficiently.
Exactly.
Sure.
It's also vital for high-frequency RF components, the things handling the signals for, say, 5G in your phone. Then there's the automotive sector. Reliability is king there. So it's perfect for MCUs, microcontrollers, the control chips, running everything from the engine management to the dashboard display.
Okay, cars make sense.
And industrial uses, too. Think high-voltage drive components, IGBTs, MOSFETs, these big, powerful modules that control motors in factories or manage power in EV chargers. Basically, anywhere you need precision, efficiency, and really good heat management, FOPLP is a strong contender.
Okay, we've got the tech. Sounds powerful. But, having it in the lab is one thing. Getting it to market, scaling it up, that's the real challenge. So where are they with that? Has Innolux actually started mass production? And do we know who they might be selling this to? Any hints on customers?
Yes, absolutely. They confirmed mass production kicked off in Q2 2025, and it's not a small pilot line either. We're talking monthly output already hitting the millions of units.
Wow, okay, so they're serious.
Very serious. It shows the process is mature, stable, ready for big clients. Now, they haven't named names, which is pretty standard in this business. But given the applications we just talked about, you can make some educated guesses. Tier 1 auto suppliers seem likely, big PMIC makers, companies building industrial control systems.
Right, the ones needing that high performance and reliability.
Exactly. And their business model here is interesting. It's a B2B service, ODM, packaging and testing. Crucially, it's often based on NRE, non-recurring engineering. That means clients pay up front for the custom design work needed for their specific chip. It makes it a bespoke, high-value service, not just churning out standard parts.
That's a clever model, especially for a company moving into a new area. But okay, let's talk money. What does this actually mean for Innolux's bottom line?
Yeah.
We know the display business can have razor-thin margins, very up and down. Is this FOPLP thing actually moving the needle financially, or is it more about the long game?
Oh, it's definitely moving the needle already. The fact that it's contributing revenue means the clients are on board, the validation's done, production is rolling, and the financial upside is significant. You mentioned the display panel margins, maybe 5%, 10% gross margin, sometimes less, very volatile.
Yeah, tough market.
It's very tough. FOPLP, though, it's a high-value, non-display product. The estimates are putting gross margins in the 15% to 30% range, maybe even higher for some custom projects.
Wow, that's a big difference.
Huge difference. So yes, it's absolutely a strategic boost to their overall financial health right now. It's a clear path towards better, more stable profitability.
Okay, we've covered the tech, the commercial side. But there's always a bigger picture, a strategy behind these big moves. Innolux's CEO, Hungjin Yang, keeps calling this a non-display transformation. That phrase really jumps out. What's the grand strategy here? Why is this more than just adding another product for them?
That phrase, non-display transformation, is key. It signals the core strategic shift.
Hmm.
They're fundamentally moving identity from being, primarily seen as a panel maker to becoming a high-end packaging manufacturer. And they're doing it by being incredibly smart about leveraging what they already have. Decades of experience in large-scale manufacturing, deep knowledge of handling glass substrates, advanced precision alignment tech for making displays.
Right, using those existing skills.
Exactly. All those skills are directly transferable to FOPLP. It's a classic example of a panel-to-package vertical transformation. They're building valuable assets and semiconductor heterogeneous integration, basically, mixing and matching different chip technologies. So no, it's not just a new product. It's about carving out a new identity, a new, more profitable position in the whole tech supply chain, finding that blue ocean away from the panel price wars.
It's a really bold strategy, using their established strengths in such a different field. But how do they stack up? I mean, the FOPLP field isn't empty, right? There are established players. Who are the main competitors, and what makes Innolux stand out, really? What's their edge?
You're right. It's not an empty field. You've got major OSATs, outsourced semiconductor assembly and test companies like ACC. They do FOPLP, but are often a chip-last version focused on things like MCUs, PMICs. Then there's PTI with their EWLB packaging, often used in consumer gadgets. Samsung's also in the game, but mostly for their own chips internally.
Okay, so established players.
Definitely. But Innolux's differentiator, their unique selling proposition, boils down to two main things. First, their commitment to the chip-first method. So we talk about the performance benefits, thermal benefits. And second, this is the big one, their unmatched capability in using large-size glass substrates. That combination, chip-first on large glass panels, is something traditional OSATs find really, really hard to copy. They just don't have that display manufacturing DNA, that experience.
Ah, so it's that unique blend of capabilities. They've found a niche that plays to their strengths. Okay, so looking ahead then, what's next for Innolux with FOPLP? Where do they take this powerful tech from here? Technically speaking, and maybe in terms of new markets.
Well, technically, you'd expect them to keep pushing the boundaries, aiming for even finer line widths, perhaps getting below 5 micrometers. That's going to be needed for future stuff like ultra-high frequency communications, maybe advanced AI chips at the edge, where density is everything.
Right, always shrinking.
Always shrinking, always packing more in. And we'll likely see more integration using SiP system in package. That means putting multiple different chips together in one package.
Yeah.
Maybe an RF chip alongside a main processor and SiC, all bundled together.
Okay, like a complete system solution in one neat package.
Exactly. And application-wise.
Yeah. Where else could this go?
I think they'll push deeper into automotive, targeting those really demanding applications needing stringent certifications, like the AEC-Q standards. Reliability is paramount there. Also, more advanced intelligent control chips, especially components dealing with high voltages, high frequencies, where managing heat and power is critical. And looking further out, next-gen power modules using those newer materials like gallium nitride GaN and silicon carbide SiDe.
Ah, again, psychers, right. Big potential there for efficiency.
Huge potential, especially in EVs, renewable energy inverters, things like that.
That's a wide range of growth areas. But how do they actually scale up to meet that potential demand? What are the practical steps to grow this new packaging business without, massive new investment?
Well, one really smart move, it sounds like they're probably doing this, is repurposing existing LCD factory space and maybe even some equipment. turning panel lines into packaging lines. That cuts down the capital expenditure needed hugely, leverages assets they already have.
That makes a lot of sense. Use what you've got.
Absolutely. Another strategy could be forming a dedicated business unit just for packaging. Give it focus, its own resources. Or maybe even forming strategic alliances with other OSATs. Perhaps they handle certain steps, Innolux handles others. Build an ecosystem. That could accelerate things too.
So wrapping this up, what we've really seen today with Innolux, it's clearly more than just a new product. It feels like a fundamental change in their business model, their position in the industry. It's a direct answer to the tough competition, the red ocean of display panels, right? And it slots them neatly into this growing demand for high-end semiconductor packaging. It's a really fascinating story of strategic pivot.
It really is. And if we pull back even further, it raises a really interesting question for you, the listener, to think about. How might this kind of move, leveraging existing, maybe even unexpected assets to jump into a new vertical?
Right.
How might that reshape other industries? Other sectors facing intense competition or maybe hitting a technology plateau. What other red ocean industries could potentially find their own blue ocean by looking at their core skills through a completely different lens?
That's a great final thought. It really highlights the power of strategic reinvention, looking at what you do well and asking, where else could this apply?
Hmm.
Definitely something to consider. Thanks for joining us for this deep dive.